Hi, my name is Saša. I'll be talking today about how to test the RxJava code, well, the RxJava2, because I hope nobody uses RxJava1 anymore. I'm currently mobile lead at Movimeo, which is a Deutsche Bank company. So we work on mobility solutions. And at the end, you will also see that we are hiring, and the link and everything. So just to let you know. So previously, I also worked for the United Nations. So now I'm going to do some marketing for them. I worked there for 3 years, and we got loads of awards. Basically, it's an app that enables you to donate to hungry school children. So it started as like a school meals program in Africa, then extended all over Asia and also Europe. So it's 40 cents to feed one child for 1 day. You can also subscribe, and if you want to get some good karma points, this is the way to do it, and it's simple. So I don't know if you used RxJava1 before. It wasn't that easy to test. So then in RxJava2, they did lots of goodies to enable testing, and they backported them to RxJava1. But one of the biggest changes were the test method. So for example, that way, for example, you can just call any observable or something and just call test, and then you have loads of assert methods that can help you. So that's like the simplest way to test it, right? So you just have your subject, your observable, and call the assert test, and then assert, and that's easy. The problem with this is that you cannot actually test subjects, right? Because if you create a subject and then send the value and then call test and everything, obviously you're going to miss out on what happened before. Basically, you need to explicitly call the test observer in this case. So basically, you can just assign it from the test method, and then you can start sending values. So it's nothing special. The thing is that they started adding loads of those assert methods with time, and some of those are not very well known. So I'm just going to go through them and show you what's in there. So for example, you have the simplest versions, which is assert value, where you just put the value that you expect. You also have the assert value count. Also, if you expect more than one value, the assert value also accepts an array, so you can just put everything that you accept to receive. And then you can also put predicates in there. So for example, you can say, okay, assert value it equals 1 or whatever. So you can also test the values inside the object. So if you have like more complicated objects in there, you can also assert no values, which is useful if you don't want actually to publish before you do something else. You can also say assert value add, so which means like if you receive 10 values, you can say, okay, I want the fifth one to be X or Y or something. You can also assert never, which means, okay, I will never receive this value. So then, as I said, there are loads of them, right? So you can say, okay, assert that this has been terminated or completed, or there were no errors, or subscribed, or conversely, not completed or not terminated, or empty, or errors, and you have loads of those methods there. So for example, when it comes to errors, you can say, okay, I want to get a specific exception. I want this exception to have a message. I want this to have this cause, because again, you can pass the predicate. There are loads of them. So one thing that people usually don't know, that there are so-called compound assert values, which means, for example, there is the assert result, right? So what does that mean? It means that it can check that you're subscribed, you got the values, there were no errors, and then it completed. So instead of putting all those like 4 or 5 or 6 different methods, you just put this one, assert result, and that's it. And you can do the same thing with the failure. Basically means, okay, it was subscribed, it got values, then it got the error, and then it wasn't completed. And the assert failure follows the same pattern as the assert error, which means, again, you can test for a message, you can test for the predicate, you can test for specific values. It's very simple to test now. There's also the assert value with values, again, as I said, with predicates, specific predicates. So one thing that you have to note when you start testing these things is that, especially when it comes to errors, and some other operators like zip, for example. So in this case, I hope you haven't seen it. It's very hard to debug. With zips, you don't have actually any guarantees in case of errors. In the sense, it will just go out to an error on the first error it receives, and it cannot recover from this. But also, if you expect to receive multiple errors, you have no guarantees which error you're going to receive first. So you might have those edge cases where you say, I'm expecting 2 different errors, and I expect this error to arrive first and the second to arrive last. That might not happen, right? So testing for specific order of errors when it comes to these operators is not a good idea. So it took me some time to figure this out. So one other good thing is with this test operator, test observer, you can also await for values. So you can say, okay, await, and then you can say just await without anything. You can say, you can put a specific number of seconds or ever time units you want to do. You can also say, okay, await for a terminal event, so it will wait for the complete or an error. You can also say, okay, await done, which is again, it will wait for the complete. You can also say await count, which will wait for a certain number of values. And you can also say there are different wait strategies for this. You can also say, okay, wait for a timeout. So this also brings us how to do testing with schedulers. So, and one of the good things about Rx is that you can do multi-threading. And it's actually one of the biggest use cases for it, at least before the coroutines and everything. But then how do you test stuff with schedulers, right? So there is the quick and dirty way, and there is the more kind of better way, like long term. So quick and dirty would be to use the global scheduler setting, right? And the second way would be to have the schedulers provider, and then you pass this provider to every object that you have. So how does it work with the global settings? So you have, I think you've all had to do this. You can set IO scheduler handler, or set various scheduler handlers, and then you would just override them for testing, right? You would just have a global setting for testing, usually the application context, and you would say, okay, set all schedules to trampoline, and that's it. So the problem with this, obviously, that then in all of the test suite, for all the tests, for all of types of these schedules, you all use one specific scheduler, which means that if you want to test something that's asynchronous, the test multi-threading, that might not happen, or specifically if you want to test some multi-threading where you want to say, okay, this will be executed 2 different threads, and I want to make sure that I get the results together. Then the other approach is to say, to use rules for testing, which means that then you can write a rule like this, and then whenever you apply this rule, it will set these schedulers, right? But that again, that means that, okay, now you don't have to use the global schedulers for the whole suite of tests, but again, the whole test class will use one specific scheduler. So that again might not be good enough for you. So as I said, there is actually a good article by Fabio Collini. He's also a GDE, and he also likes to talk about RxJava a lot. So you can see how to use this with Mockito and other stuff. But then, for us, the only long-term viable strategy was actually to pass like a schedulers provider, right? So you would say, okay, in every class I'm going to pass a scheduler provider, and then I'm going to ask it for the certain schedulers, like the UI or computation IO. And then, for example, in the application, you will have the regular schedulers, like, you will give the main thread and the real computation, the real IO, whereas we would have, in certain tests, you might have trampoline scheduler provider, and then you would just send everything to trampoline. So the problem with this approach is obviously it impacts the architecture. So this means that you need to pass these providers to every class manually. So you have to have it in the constructor, you have to inject it Dagger. And that will mean that you need to change a lot of your structure. Sorry. So one other thing that's useful is to test scheduled actions. So obviously, once you start doing asynchronous stuff, this will be one of the biggest problems. Like you want to assert that something happens after you've done something else, or before you've done something else, or together with something else. So, for example, if you have an example of this, you say, okay, I want to, schedule some actions on the worker that increment, do some things. In this case, it's just a simple incrementer, right? So then, how do you do this? If you just use the regular test scheduler, you will see that those actions are not actually triggered. That's because this test schedule actually have a specific trigger actions method, which means that everything that was scheduled to happen will happen only after you call trigger actions. So in this specific case, you will see that nothing gets executed, and then you trigger the actions, and then everything magically works. So the thing is, how would you then test the timeout, right? So if you just say, okay, you have observable never or something, and you say, okay, just put a timeout on 5 seconds. And if you say, okay, I'm going to receive a timeout exception, obviously that's not going to happen, right? So by default, that's because by default it uses the computation scheduler, right? So again, going back to the previous, settings, schedules that you want to have in tests or something, you have to make sure that if you use the schedule as provided, as in the provider, then you have to pass one of those, and then in the tests, those provided schedules will be replaced by the ones that you want to have a test. Otherwise, he would use computation, and he wouldn't actually do that much. So again, as I said, you would pass this scheduler, and then in the case of this timeout, you say, I want to test a timeout after 5 seconds or something. Then you have the advanced time by, which means, okay, now on this schedule, let's just presume that 5 seconds have passed, and then after that, you will get a timeout which you're waiting for. So you can also create test schedulers with time. So for example, you can say, okay, set this time. You can also use a directory on the scheduler. And you can also create it with, you can also check what the time is currently in the scheduler. So in case you have some more complicated stuff, you can easily test that if you have like multiple times and multiple moving stuff, you can say, okay, I want to test that now I'm at this point of time. Again, depends on how advanced your Rx stuff is. So now actually, I know that organizers here will be surprised, but I intentionally made these slides smaller than usual, because then there are usually lots of questions after this. So I do hope you have some questions. So so if you want to read more, obviously you always have the the RxJava2 testing slides. You also have the intro to RxJava, which is a nice page that's always updated. So I'm open for your questions now, or whatever you want to know more about Rx and testing. Okay.
About the weights that you mentioned,
Mm-hmm.
What is the best practice? What you're using more often? You mentioned a couple of weights that we can use. So
Yeah.
what is the best practice?
There isn't a best practice. So as I mentioned, the idea is to pass the schedulers providers, so you can control each scheduler in every test. There isn't. You just have to see what works for you. I've had these experiences mostly with payment systems, because I had, when I worked for Shadow Mill, we had these payments where you can come from PayPal or from Google or from Braintree credit card. So we had to synchronize everything, because you have to juggle their tokens and their initialization methods, and then you have to make sure that your transaction went well and everything. So it was just okay, just I have like 3 or 4 different transactions, 2 of which can occur at the same time, and one has to arrive after the other, and then you could also have, in this case, you can have the token that's expired, so you have to renew the token, so you have to come back into this. So it was just lots of manual like testing and see what works. I didn't find any like best practices also because they're all methods that you can use on basic RxJava code. It just depends on how you use them. Yeah. Other questions? Really? Okay.
Can you explain me a bit what is its intention or what can use?
Okay, so RxJava was created a few years ago by Netflix. The idea was to provide kind of asynchronous network for Android, basically, because at the time on Android you only had the async tasks, and that was it. So the problem with async tasks is they are not re-entrant, right? You cannot say I'm gonna restart an already existing async task. You can just create a new one, which means that in the code you always have to have those. I'm gonna create a new one. You don't have you can just have this instance, but then you have to kill it and create a new one. So, and then you also have the callback hell. So for those reasons, they created RxJava, which is basically a kind of they call it reactive programming. That's basically kind of version of functional programming, like a simplified one. The thing why we use it on Android is, or we used to, was that you have lots of control over multithreading. Because on Android, multithreading was a mess, and it still is. So with this, you have schedulers. You can say, okay, just do this on I/O, do this on UI, do this on computation. You don't have to set like thread pools because computation and I/O, they already have their own thread pools, and I/O is unbounded, which means you can have as many as you want. Computation is limited to the number of CPU cores and divided by 2. That's how it was at the beginning. So you have like a simple way to do multi-threading, and you can also easily synchronize tasks or repeat them or retry them, or you get notified if there is an error or something, right? So for me, that was the biggest takeaway when I started working with this, because I actually started working with RxJava before there was RxJava. Because this comes from .NET, actually, from C#. And in my previous company, we wrote our own version of RxJava because we copied stuff from C#. So we really started doing this, and it was a great help because we worked on sports events, on video streaming for sports events. And the idea was, I'm going to have like a streaming video, and then I'm going to have overlays with data over those videos. For example, like a football match, right? So you have the statistics, and then every second you would refresh, and you would show, okay, there was a goal and there was a foul, and you would show the heat map, you would update the heat map, all that stuff. So all this was done with this pre-Rx reactive framework, and it worked very well because basically you would just say, okay, from the architectural standpoint, you would say, okay, this part of the screen, let's say you have a heat map, just subscribe to this subject. And whenever there's something, you just refresh the heat map, and that's it. So you could easily split pieces of code or pieces of screen in this case to just correspond to a specific data that's been updated, right? So that's currently what Android did after like 8 years with live data and architecture components, right? So you have this same idea, okay, you can subscribe to something, and you can send data to it, and it will update just one specific part. Obviously, they are just at the beginning, so their view models are not very good, and the live data is not very good, but better than nothing. So the thing is that now we also have Kotlin and coroutines, so you can use those to control the multithreading, right? So if you want to have something something simpler, you can execute like 1 or 2 or 3 things at the same time or synchronize them. You can use coroutines, so you don't need to use RxJava for this anymore. So so now RxJava is kind of fading out, which I actually think is a good thing, because now you can use RxJava only when you really need RxJava, when you really need reactive programming, which means synchronizing and desynchronizing different things and having some more complicated things than just using them instead of asking tasks.
Okay, so it's really more focused on, actually totally focused on front-end part, and it has nothing to do with the back-end part. So that can be in either what, C# or really?
Well, C#, you have this in C#. Like if you use C#, .NET, or if you use Link, you have reactive programming. So that's already there. Also, RxJava is used a lot, was used a lot on backend. Now, for example, in our company, we use Scala, we use Kotlin. So Scala, they already have certain kinds of things that are similar to this. And Kotlin, they mostly use coroutines because on the backend, you don't have that much complicated stuff, usually. But for example, we did it, as I said, we worked on some sports events. We also worked on the Olympics. And we had a backend written in C# with reactive programming, and we treated, I think at the most was like 10 million messages per second. So for the whole of Olympics during 14 days, there was only one message that got lost, which, you know, not bad. And that was like, what, in London, so that was, what, 6 years ago? And also in Sochi, that was 4 years ago. So, you know, and that was with the .NET, and then with RxJava, again, it worked even better.
Okay, so do you have test developers who write those tests, or they're usually written by developers? So do you have a separate role for writing automated tests or not?
Well, these kind of tests, they would be written by developers, right? Because these are unit tests, so like you would try to do something similar to TDD. So you would try to write tests first and then the result. But then, for example, with RxJava, it's usually hard to see how you need to write certain things. You really need to start doing it and you see, okay, I forgot this, I need to add this, depending on what you're writing. Okay.
That's all for me, thank you.
Okay, thank you. So, more questions? No? Okay, then thank you for coming, and I hope it was interesting. And also, I'm gonna post these slides to Twitter, and also on the GrowIT page. So, thank you.